This is SpaceTime, Series 21, Episode 98, coming up on SpaceTime. Our first chance to listen to sounds from the Martian surface, how the Earth was made, and blast off for the first mission to land on the far side of the Moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars InSight lander has sent back the first audio recordings from the Martian surface. InSight sensors captured these haunting first-ever sounds of winds blowing across the red planet's surface just days after successfully touching down on the Elysium Planitia, a broad, flat, freeze-dried lava plain that straddles the Martian equator just south of the Elysium volcanic province. The sounds are actually a low rumble caused by vibrations from the wind, estimated to be blowing from the northwest at between 5 and 7 meters per second. The winds are consistent with the direction of dust devil streaks in the landing area, which were observed from orbit. InSight principal investigator Bruce Bannert from NASA's Jet Propulsion Laboratory in Pasadena, California, says capturing this audio was an unplanned treat. It came about because two very sensitive sensors on the lander detected the wind's vibrations. One was an air pressure sensor inside the lander. The other was the seismometer sitting on the lander's deck, awaiting deployment by InSight's robotic arm. The two instruments recorded the wind noise in different ways. The air pressure sensor, which is part of the auxiliary payload sensor subsystem designed to collect meteorological data, recorded the air vibrations directly. On the other hand, the seismometer recorded vibrations on the lander itself, caused by the wind moving over the spacecraft's 2.2-meter diameter solar panels. These sensors are capable of detecting vibrations at frequencies of nearly 50 Hz at the lower range of human hearing. The solar panels on the lander sides respond to pressure fluctuations from the wind. And when mission scientists looked at the direction of the vibrations coming from the solar panels, it exactly matched the expected wind direction at the landing site. Unlike the vibrations recorded by the seismometer, the audio from the air pressure sensor is at about 10 Hz, below the range of human hearing. This raw audio sample from the seismometer was released unaltered, followed by a second version raised 2 octaves in order to be more perceptible to the human ear, especially when heard through a laptop or mobile speakers. The audio sample was then sped up by a factor of 100, which shifted it up in frequency. This is the only phase of the mission during which the seismometer will be capable of detecting vibrations being generated directly by the lander. That's because in a few weeks' time it will be placed on the Martian surface by InSight's robotic arm. It'll then be covered by a domed shield to protect it from wind and temperature changes. Mind you, it will still be able to detect the lander's movements, but they'll be channeled through the Martian soil. For now, it's recording vibrational data which scientists will later be able to use to cancel out noise from the lander when the instrument's on the surface, allowing them to focus on detecting Mars quakes. When earthquakes occur on Earth, their vibrations, which bounce around inside the planet, make the planet, sort of ring, similar to the sound a bell creates. InSight will confirm whether tremors or Mars quakes have a similar effect on the red planet. It'll detect these vibrations and in the process tell scientists about the red planet's deep interior composition and structure. NASA's Mars Interior Exploration using Seismic Investigations, Geodesy and Heat Transport, or InSight mission, is the first probe designed to directly study the interior of another planet. It'll study the structure of the Mars' deep interior, allowing scientists to better understand the formation and evolution of the red planet. InSight was launched aboard an Atlas V rocket from Space Launch Complex 3 East at the Vandenberg Air Force Base in California on May 5, 2018. It was the first interplanetary mission to be launched from Vandenberg. InSight landed on the Elysium Planitia on November 26, 2018, for what will be a 2-year mission. The lander is deploying two instruments directly onto the red planet's surface using its robotic arm. One is the seismometer we've been talking about. It's designed to measure microscopic ground motions, providing detailed information about the interior structure of Mars. The seismometer is so sensitive, it'll also detect atmospheric waves and gravimetric signals, that is, tidal forces from the Martian moon Phobos as it orbits above. The seismometer is supported by a suite of meteorological tools designed to characterize atmospheric disturbances that could affect the experiment. These include a vector magnetometer to measure magnetic disturbances such as those caused by the Martian ionosphere, a suite of air temperature, wind speed and wind direction sensors, and a barometer. The other instrument being deployed by the 2.4-metre robotic arm is a heat flow probe, which will hammer itself up to 5 metres into the Martian soil. As the probe burrows down, it'll release a trailing tether embedded with heat sensors. This should provide unique information about the planet's interior and how it's evolved over time. InSight will also track the lander's radio to measure wobbles in the planet's rotation that relate to the size of its core. A suite of environmental sensors will monitor the weather and variations in the magnetic field. You're listening to SpaceTime. I'm Stuart Gary. New researchers confirm that planet Earth was formed relatively quickly some 4.6 billion years ago, accreting directly out of the protoplanetary nebula of gas and dust surrounding the Sun. The findings, reported in the journal Nature, come from crucial evidence from water and gases trapped in the planet's mantle. The study's authors, Professor Sujal Mukhopadhyay and Curtis Williams, both from the University of California, Davis, wanted to understand where and how the neon in the Earth's mantle was acquired. This would in turn tell them how fast and under what conditions planet Earth formed. The neon was used as a stand-in for where water and gases like carbon dioxide and nitrogen came from. Unlike these compounds, which are essential for life, neon is an inert noble gas and isn't influenced by chemical and biological processes. So, neon keeps a memory of where it came from even after 4.6 billion years. There are three competing hypotheses about how the Earth formed from the protoplanetary disk of dust and gas, and how water and other gases were delivered to the growing proto-Earth. These different models have consequences for what the early Earth was like. The first model is known as the Solar Nebula or Early Rapid Formation model. According to this hypothesis, the planet grew relatively quickly over just 2 to 5 million years, capturing gas directly out of the protoplanetary nebula, the swirling cloud of gas and dust surrounding the young Sun. The second hypothesis, known as the irradiated particles model, suggests that dust particles condensed and were then irradiated by the Sun for some time before coalescing into small planetesimals that were subsequently delivered to the growing planet Earth. The third option is known as the late accretion model. According to this hypothesis, the Earth formed relatively slowly, and the key signature gases were delivered by carbonaceous chondrite meteorites, rich in water, carbon and nitrogen. If the Earth came from carbonaceous chondrites, its hydrogen would have come in the more oxidized form of water. To figure out which of these three competing hypotheses on planetary formation and delivery of gases were correct, the authors needed to accurately measure the ratios of neon isotopes trapped in the Earth's mantle when the planet was formed. Now, neon comes in three isotopes. There's neon 20, 21 and 22. All three are stable and non-radioactive, but neon 21 is formed through the radioactive decay of uranium. So that means the amounts of neon 20 and 22 in the Earth have been stable since the planet formed and will remain so forever, but neon 21 will continue to slowly accumulate over time through radioactive decay. The three different hypotheses for the Earth's formation are each predicted to have a different ratio of neon 20 to 22. One of the problems for the authors is that they couldn't really sample the mantle directly. Instead, they had to use rocks known as pillow basalts, which are found on the ocean floor. These glassy rocks are the remains of magma flows from deep in the Earth that spilled out and cooled on the ocean floor. Samples were collected by a drilling expedition led by the University of Rhode Island, which made its collection available to other scientists. The gases would be found in tiny bubbles sealed within the solidified basalt. Using a press, the authors cracked basalt chips in a sealed chamber, thereby releasing the gases, which could then be analysed by a mass spectrometer. Previous studies had already established the neon isotope ratio for the Solar Nebula or Early Rapid Formation model, with data from the Genesis mission which captured particles of the solar wind. Data for the irradiated particles model came from an analysis of lunar soils and from meteorites. And of course, carbonaceous chondrite meteorites provided data for the late accretion model. The authors found that the isotope ratios from their basalts were well above those expected for either the irradiated particles or late accretion models. So this means the Solar Nebula or Early Rapid Formation model, in which the Earth grew relatively quickly over 2 to 5 million years, capturing gas from the protoplanetary nebula, was the most likely planetary formation scenario. I'm Stuart Gary. You're listening to SpaceTime. Astronomers gazing across some 321 million light-years of space into a monstrous city of galaxies have discovered thousands of globular clusters. Globular clusters are some of the most ancient structures in the universe. They're composed of tight gravitationally bound spheres, each containing thousands to millions of stars, which were all originally formed at the same time in the same molecular gas and dust cloud. Globular clusters contain some of the oldest known stars in the universe, giving astronomers a glimpse into the conditions of the very early cosmos more than 12 billion years ago. Most galaxies contain populations of globular clusters orbiting in their halos. The Milky Way has at least 150. This new population of more than 22,426 globular star clusters was detected scattered throughout a massive concentration of galaxies known as the Coma galaxy cluster. The Coma cluster, also known as Abell 1656, is a huge cluster containing more than 1,000 galaxies. Along with the Leo cluster, also known as Abell 1367, it's one of two major clusters comprising the Coma supercluster, a huge city of galaxies in the northern constellation of Coma Berenices. The new survey, reported in the Astrophysical Journal, will allow astronomers to use the globular cluster field to map the distribution of matter and dark matter in the Coma galaxy cluster. Because globular clusters are much smaller than entire galaxies and much more abundant, they're a much better tracer of how the fabric of space is distorted by the Coma cluster's huge gravitational impact. In fact, the Coma cluster was one of the first places where observed gravitational anomalies were considered to be indicative of a lot of unseen mass in the universe, the stuff which later became known as dark matter. The Coma galaxy cluster's globular clusters were detected using NASA's Hubble Space Telescope. The survey found the globular star clusters were scattered in the space between the galaxies. It appears they've been orphaned from the galaxies they originated in due to galactic near collisions inside the traffic jam-like Coma cluster. Hubble revealed that some of these globular clusters are lining up in bridge-like patterns. That's a telltale sign of interactions between galaxies where they're gravitationally tugging on each other, pulling off tidal streams of stars, gas and dust. The study's lead author, Juan Madrid from the CSIRO's Australia Telescope National Facility, first thought about the distribution of globular clusters in Coma when he was examining Hubble images showing the globular star clusters were extending all the way to the edge of any given photograph of galaxies in the Coma cluster. Madrid then looked for more data from one of the legacy surveys of Hubble, known as the Coma Cluster Treasury Survey. However, halfway through the program in 2006, Hubble's powerful Advanced Camera for Surveys, the ACS, suffered an anomaly. To fill in the survey gaps, Madrid and colleagues painstakingly pulled numerous archival images of the Coma cluster taken from a variety of different Hubble observing programs, and developed algorithms to sift through the images that contain at least 100,000 potential sources.
Well, we found more than 22,000 globular clusters within the Coma cluster of galaxies. So that's what we can call clusters within cluster.
You've also found that unlike, say, around the Milky Way, where we have, 150 or so globular clusters, clusters don't necessarily stick to one particular galaxy when you're in a huge galaxy cluster.
Right. So that's a very good point. So we know that the Milky Way has 150 globular clusters, as you said. We have been studying them for a very long time, for decades. But with the Hubble Space Telescope, we discovered that other galaxies beyond the Milky Way also have globular clusters. And the Hubble Space Telescope is really a fantastic instrument with fantastic cameras and whatnot. But the one drawback of the Hubble instruments is that the field of view is very small. So we have been discovering that most galaxies have globular clusters, but we have always been studying the neighborhood that is just around the galaxy, or the area that we see on the sky that is around a parent galaxy. So what we did here is that we combined 26 different pointings, what we call pointers, 26 different images. And we were not only looking close to galaxies, but in all the space in between galaxies. And indeed, we discovered that there are really thousands of globular clusters in that intra-cluster space, in the space between all the different galaxies.
Your work's focused on Coma cluster. Why Coma? Why did you choose that?
Okay, Coma is a favorite of astronomers. So there are two nearby galaxy clusters to Earth. One of them is Virgo, and the second one is Coma. And Coma is much, much larger than Virgo. Coma has something like 2,000 galaxies belong to this Coma cluster. It's really the largest galaxy cluster that is closest to Earth. So Coma has been studied for a long time. It's one of the favorite objects for astronomers on Earth to study all the effects that really these huge clusters have.
And as well as being large, it's also in a good position, isn't it?
It's in a fantastic position in the sense that there are very few stars in the field. So when you're studying distant objects, you have a really bright star in the foreground, but a star may saturate your detector and whatnot. It will bring some issues for your data analysis. Coma doesn't have that, very few stars. So it's I'll say like a very clear view. We have a very clear view of Coma from Earth.
Putting together, I guess, a mosaic of different surveys, you're able to draw a pretty good picture of the central part of Coma, and you saw all these globular clusters, these star clusters in the space between the galaxies.
Yeah, indeed. And look, Stuart, last weekend I was walking around the Blue Mountains. I saw this fellow, taking different snapshots of the view that you have of the fantastic Blue Mountains. And now with all these processing techniques that modern cameras have, you can put together all these different snapshots into a really nice panorama. So this is what we try to do. We just try to put together a wide field of view, sticking together different exposures, different pointings taken by the Hubble Space Telescope, and to image not only galaxies but all the space that was between them. That way we're able to create this wide field map of globular clusters. And one of the interesting findings of this paper is where for the first time we're able to really find this larger scale distribution of globular clusters in Coma. And as you said at the very beginning, we were able to find that they accumulate in three large clumps, and we're able to actually measure the radii of these different clumps of globular star clusters, and that's something that hasn't been done before.
By looking at these things and by measuring the radii, is that giving you an idea of how space within a cluster is sort of structured?
Yeah, well, look, one of the...
I guess I'm sort of leading to dark matter and things like that here.
Yeah, I think I had a sense that you wanted to go there. But before we go into dark matter and all that stuff, I will say that the origin of star clusters is one of the big enigmas of current day astronomy. We have been studying star clusters for a very long time, and now we understand quite well many different aspects of star clusters, like the dynamics. Each globular cluster is a collection of around 1 million stars, and we do understand to a certain extent very well how these stars move within the star cluster and what is the stellar evolution and whatnot. So we have made really great progress.
When we think of globular clusters, the current best theory that involves these all being originally formed at the same time. I mean, they've evolved and there have been new generations since, but they were originally formed in the same molecular gas and dust cloud.
Right.
The other idea is that they're simply the dense cores of galaxies that have been gobbled up by other galaxies.
Absolutely. And those are the current theories for the origin of globular clusters. And getting to know where they are within a cluster of galaxies, I think will help us definitely try to better understand the astrophysical origin of these systems. Yeah.
And by looking at how these interactions are taking place, does that tell us something about the nature of dark matter, this halo of dark matter that's surrounding these galaxies, or is it?
Yeah, well, right now I think in astronomy and astrophysics, we have a really big challenge, which is to understand the nature of dark matter, because we only understand, I will say, like a small percentage of all the stuff that galaxies are made of. So all the stars and all the light of the galaxies is only a percentage of the material that build galaxies. So we're still studying all the objects in the universe that emit light. So that's what we can detect. And we have, we have been studying the rotation curves of galaxies using stars and whatnot in order to derive the amount of dark matter on each galaxy. That's what we do. We look at the different stars, and then we go back and derive a velocity profile, and we say, oh, this galaxy contains, I don't know, just to give you a number, 50% of dark matter. Now with globular clusters, we can also use globular clusters as tracers of the potential well of a galaxy cluster, for instance. By using these globular clusters as tracers of the potential well, we can go back and derive the amount of dark matter in a galaxy cluster. And I think if memory serves, I think the very early work of Zwicky, he postulated the existence of dark matter based on observations of the Coma cluster.
That's right, yes.
By studying galaxies in the Coma cluster. And given that star clusters are just a fraction of the mass of a galaxy, and they are way more abundant in a galaxy clusters, these small guys can be used as tracers of the potential well and all the matter that is present in a galaxy cluster.
That's Juan Madrid from the CSIRO's Australia Telescope National Facility. And this is SpaceTime. I'm Stuart Gary. China has launched its long-awaited mission to land on the far side of the moon. Beijing's Chang'e-4 lander was launched aboard a Long March 3B rocket from the Xichang Satellite Launch Center in northwestern China's Sichuan province. It's expected to touch down in the von Karman crater on the lunar far side in early January. This 186-kilometre-wide crater is part of the massive South Pole Aitken Basin, one of the largest impact craters in the solar system, spanning some 2,500 kilometres across. The Chang'e-4 lander includes a small rover which will explore the local terrain. By the way, Chang'e is the name of the goddess of the moon in Chinese mythology. As part of preparations for this historic mission, Beijing first launched the Quaigo communications satellite back in May. Quaigo, Chinese for Magpie Bridge, was placed into the gravitationally stable Earth-Moon Lagrange 2 position, some 60,000 kilometres above the lunar far side surface and in visual line of sight with the Earth, thereby allowing mission managers in Beijing to maintain contact with their lander and rover once they arrive. The Chang'e-4 is equipped with 8 scientific instruments, many of which have been supplied by space agencies around the world. Ironically, it also features technology smuggled back to China by Aspiring, which infiltrated American universities working with NASA. Its 8 scientific instruments include landing, panoramic and terrain cameras, ground-penetrating radar, as well as low-frequency and visible and near-infrared spectrometers. This equipment will allow Chang'e-4 to study surface and subsurface composition in the hope of determining why the lunar far side is so different from the huge, dark basaltic Maria-covered near side of the moon. A biological experiment includes silkworm eggs, as well as seeds from tomato, potato and Arabidopsis plants, all housed in a miniature biosphere designed to study seed respiration and photosynthesis on the moon. The mission will also study radio astronomy using Quaigo in order to gather data on the radio environment of the far side of the moon for future lunar-based telescopes which will be shielded from the radio noise of the Earth. The mission follows on from the Chang'e-3 lander and Yutu or Jade Rabbit rover, which touched down on the lunar near side back in December 2014. The project's all part of China's ambitious plans to set up bases on the moon in order to mine the vast lunar resources of helium-3. You're listening to Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. The COP24 climate summit in Poland has released data showing carbon dioxide emissions from fossil fuels have risen dramatically for a second year in a row. That's despite enormous growth in renewable energy. The new findings, reported in the journal Environmental Research Letters, predicts that 2018 will see the year end with a more than 2% increase in global carbon emissions compared to 2017 levels. While countries in the West, including Europe and Australia, are continuing to cut their carbon emissions, the massive emerging economies of India and China are continuing to increase the amount of carbon dioxide they're pumping into the atmosphere under the Paris Agreement. The study by the CSIRO found that the bulk of this carbon dioxide is coming from oil used to power cars, trucks, aircraft and shipping, and from the use of gas in industry. The study also found coal remains a strong contributor despite declines in many Western countries. The simple fact is, strong growth in renewable energy and electric vehicles has not been enough to counteract the rising emissions from the growing economies of China and India. In Australia, emissions in all sectors except power generation have also been growing, with the just-released June quarter emission data showing a continued upward trend. A new study claims kids born into a family which already has a child with either autism spectrum disorder or attention deficit hyperactivity disorder is more likely to also be diagnosed with one of these two disorders. Both autism and ADHD share common genetic factors and biological influences, leading researchers to suggest this may be why both conditions run in families. The findings, reported in the Journal of the American Medical Association, notes that while scientists knew each condition can be genetic, they didn't know, at least until now, how likely it was for a later child to receive either diagnosis. A new study has discovered zombie bacteria and some of the world's hottest living organisms thriving deep under the Earth's surface. The findings by scientists with the Deep Carbon Observatory are being described as the discovery of a sort of subterranean Galapagos. In fact, the study estimates the deep subsurface biomass equates to more than all of the humans on Earth put together, about 600 billion cells. Among the findings are microbes living at the very extremes of survival, including a front-runner for the Earth's hottest organism, a single-celled microbe which thrives in 121-degree temperatures on the seafloor. Well, it sounds too good to be true, but a novel approach that may allow you one day to eat as much as you want without gaining weight could become a reality in the near future. Scientists at Adelaide's Flinders University have found that the removal of a gene known as ARCAN1 resulted in a failure to gain weight even after gorging on high-fat foods for prolonged periods. There are two types of fat in the human body, brown fats which burn energy and white fats which store energy, and it appears blocking ARCAN1 helps transform unhealthy white fat into healthy brown fat, in the process presenting a potential treatment method in the fight against obesity. The scientists developed a series of drugs which target a protein the ARCAN1 gene produces. They're now testing the drugs to see if they inhibit ARCAN1, representing a potential anti-obesity drug, by burning more calories while people are resting. 2/3 of Australian adults and a quarter of Aussie kids are either overweight or obese, and the statistics are just as concerning in the United States and Britain. Intelligence agencies are warning of a new cybersecurity attack being mounted by Chinese government hackers. The new attack, called Cloudhopper, has been blamed for a surge of activities over the past few months. Unlike other Chinese government-sponsored cyber attacks, which have been undertaken by agents of the People's Liberation Army, Cloudhopper is being attributed to the Chinese Ministry of State Security's Tianjin Bureau's App 10 department, using the codename Stone Panda. Almost half of all cybersecurity attacks investigated in 2018 originate from China or Russia, closely followed by Iran. With the details, we're joined by Alex Zaharov-Reutt from IT Wire.
Reports say that this is China taking the gloves off in hacking attacks. It's like when viruses used to be pretty mild, they were just sort of annoyances, and all of a sudden they started deleting files and encrypting everything on your computer, and a virus attack was a real thing. This Cloudhopper is meant to be a new campaign, started in 2016, where there's been this resurgence of Chinese attacks, and according to reports, it's surpassed Russian activity. And so there's been reports out there that talk about data breaches from major telcos, just talking about how these supposedly state-sponsored Chinese hacking operations are now really stepping up the mark, and they're looking for very specific information with spear phishing attacks and whatever they can do to break in and get that information. It's only natural that there's an upgrade in the capabilities of the bad guys. They might initially be trying to just sort of see what defenses they can break through. But then they start turning up the heat and you start seeing real damage. We saw it in the Ukraine with some of the WannaCry, not Petya, where they purposefully shutting down utilities in the Ukraine, but shutting down hospitals in the UK and other businesses around the world. So look, it's really just a case that the cyber war is real. I mean, if there's a third world war, it's happening right now. It's a cyber war. It's only going to get worse.
And that report by Alex Zaharov-Reutt from IT Wire. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpacetimeWithStuartGary.com, or from your favorite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.